Okay, so we're now going to have a look at the same process. So I've left exactly the same step-by-step notation on the board, the same table. It's exactly the same as the last question, except now it's not obvious where in the middle is. So if we have this shape cut out of card and we're trying to balance it on our finger, it's not, to me anyway, obvious where in the middle is. It's going to be somewhere around here, and maybe a bit off to this side because it's a bit heavier on this side than it is on this side. So it shouldn't be in the middle, it should be a bit across this way. And whether the circle or the triangle weighs more, I'm not quite sure. So I expect it to be in here somewhere, but I don't know exactly where it is. And I need to be able to find that out exactly. So we're going to go through the same process we went through before and see how we go. Okay, so the first step is to decide where we're going to do our measurements from. So bright ideas as to where you want the measurements from on this one. Somewhere on it is good. Top left. Yeah? Yeah? Okay, what's not great about that point? You've got to go some up and some down. So there might be a better point than that one. Top right. So up here. Take your measurements from there as your origin. Then you're measuring everything to the left and everything down. Well, if we define left as being the way we're going to measure, so X we're going to mean by X, in this case we're going to mean left, and Y we're going to mean down. Yes, you could use negative distance, and your answer would come out with negative in it, which, yeah, as long as you're consistent, it doesn't matter. But if you're going all one direction, you don't have to worry about making it negative. Just know everything's in that direction, which is the drama with Nathan's suggestion of going here. Then that would have to be positive and that negative, or vice versa. So you have both. So, yeah. That should work. Okay, so step 2 is to break it up into obvious shapes. So how many shapes and what are they here? 3 shapes, and the shapes are semicircle, triangle, and rectangle. So if we basically put a line here and here, and A, B, C, we'll do. And coincidentally, this table I prepared earlier has an A, B, C on it. So 3 shapes was good. I didn't have to slip an extra line into my table for a 4th shape. Okay, so we need to work out the area of these 3 things. So we do need to know how to work out the areas of triangles and semicircles. It's part of the deal, which you're not going to be given on a formula sheet, so you need to know those things if you need them. So the area of A is going to be, that's a triangle, so the area of a triangle is half base times height. So half of 250 times 100 be 125 from a couple of zeros. Sound good? Yep. Question. How deep the semicircle is? What do you reckon? Suddenly recon, yep, okay, this is the question that someone else nodded at me before. You actually know you've got the information you need. So this is a bit out of order. Let's do the rectangle, and then we'll come to the semicircle. So how big is the rectangle? 700 by 250, which is 175, isn't it? Yep. 3 zeros. Okay, and now we come to the area of the semicircle, and we can work out the area of a semicircle, or the area of a circle. Area of a circle, either pi r squared, or where I was heading towards, pi d squared over 4, or pi r squared, either's fine. But in this case, we know the diameter, don't we? So if we use pi d squared over 4 with 250, sorry, that's a bit crazy. Gone nuts. Thank you. That would be a stupid, that'd be a weird number, that one. Okay, so if we use d as 250, chuck it into that, and then halve it, we'll have the area of the semicircle. Someone's just done. What have you got, Nathan? I thought you were doing it. No? Someone's got to be confident here. Who's got a triple own calculator? Say again, 2. It's 0.7. It's 0.7. Let's round it up to 4. So we're going to the nearest square millimetre. Anybody else do the same and get the same answer? People got different answers? I mean, at least 2 or 3 people getting the same answer before I'm confident to go with it. Something different, Shane? Anybody else? You got the same? Yep. Oh, you got the same? Yep, okay, cool, good to go. All right, we've got 3 people with the same answer, we're all good. Okay, so those are the areas. So now we need to work out the lifts and the downs. So let's start with the, oh, okay, what is it? I thought you had it there, Nathan, when you say, do you want to do the total? No, sure, we'll just pause while Nathan does the total for us. Let's wake us up when you got there, will you? Okay, so you got a different C, Shane, is what you're saying? Okay, so roughly, ballpark figures, D is 250, squared that's going to be, this is good? Yeah, there's no argument with that. The question is, are we all confident with this number? Yeah, I agree with that, if this is right. Is everyone happy with that one? Shane's not. So Shane is, okay, so what we should be doing here, Shane, is pi times D, 250 squared, all of that divided by 4, and all of that divided by 2, because it's a semicircle. Try that and see what you come up with. Okay, so that's just the formula, and then divide by 2, because it's only half a circle. And then 43.7, round up, yeah, okay. So we're all good now? Yes, okay, we're all good. And we agree that if we add those 3 numbers up, we get this number. Yes, okay, sure, okay, we've done the area. So I told you it was a more complicated shape, we can't even work out the area. Okay, so now we're looking at the left. So how far left do I have to go from here to get to the middle of any given area? So which areas are easier to do? Yeah, so we're coming a line down here, moving across to the middle of a particular shape. So which shapes are obvious how far you have to go across? B and C, and how far across do you have to go to get the B and C? 1, 2, 5 for each of them. Yep, 1, 2, 5 for each of them. Okay, so that's, everyone happy with that? That's obvious where those things are? Okay, A is not quite so obvious. Because if we come across 1, 2, 5, that's not the middle. This side has got more than that side. So it's got to be somewhere in here. And the answer is indeed 1/3. Okay, so whenever you're dealing with a right-angled triangle, that really wasn't. If you're dealing with a right-angled triangle, the center point is 1/3 of the height and 1/3 of the base from the right angle. Okay, so it's got to be 1/3 from the right angle. It's not, if you're measuring from this side, it wouldn't be 1/3. It'd be there, which clearly isn't even. It's 1/3 from the right angle. If it's not a right angle triangle, then it's the 1/3 from the median. You can always break it. If you've got a triangle which is not a right angle triangle, you can always do that and make 2 right angle triangles. Yep. And so at this stage, simple shape is a right angle triangle. All right, cool, happy with that. So in this case, how far across do I have to come here? 83.3. Yep, okay. So for a triangle, 1/3 from the right angle. So it's always, every time, back to the origin, across to the middle of A, back to the origin, across to the middle of B, back to the origin, across to the middle of C. And now we're going to do the same for Y, which we've decided is down. So the question is, from the top, how far down do I have to go to get to the middle of each of these things? Okay, so 2 of them you should be able to do now. One's obvious, one's a wee bit of calculation, and then we'll talk about the other one. So which one do I have to go at? For A, yep, so A is 66.7, yep, because it's 1/3 of the way up from the right angle or 2/3 of the way down from the top. So it's 2/3 of 100. Awesome, agree with that? What about B? What's B going to be? 450? No, it's including the 66 because you're going from the start, that 100 plus half of that 700. Yep, so 350 plus that 100 is 450. Okay, which brings us to the semicircle. How far do we have to go to make a semicircle work out? Okay. And again, if we come half of the way down the semicircle, it's not even. The top is bigger than the bottom. So it's got to be something which is a bit less than half. And it's not a simple number, but there is a formula for working it out. So if we have semicircle of radius r, and we're trying to find the distance to the centroid, so that distance is 4r divided by 3 pi. And that works for any semicircle. And that's a formula, if you need it in the exam, you'll be given it. So if you've got one of these things with a semicircle in the exam, they'll give you that formula. Okay, so for this one here, the distance, that distance there is 4r over 3 pi. It's 4 times the radius is 125 over 3 pi, which is 106. Okay, some number other than 106. It's good the way we can rule out one number. There's only an infinite numbers left after we've ruled out one. What is it? It's going to be about 61 or 62, somewhere in that area. 63, somewhere early 60s. No, it's not. I'm lying horribly. Early 50s. What do you got? 53.1, we'll call it. 53.1. 53? 53 point, what'd you get? 53.05. Let's round up to 0.1. 53.1. All right, so we're going with 53.1. Oh, is that the right answer to write in that box? Why not? Because I've got to start from the origin. So it's 100 plus 700 plus 53. So it's 853.1. Always got to measure from the origin. So right back to the top, 100, 700 is 800 plus the 53. Okay, and now we do the same as we did last time. We multiply these things across the tables. So who's done a few of them? You can yell out some numbers for me. Just this box here, Karen. Okay, say again. 1041250. Awesome. Any others done? 21875,000. Yep. Is it here or here? Okay, it's from here, yep. Yep. Brilliant. lost that in the middle of someone's cough. 20938. There is some ettering. Say again, Shane. 251. Right. Cool. Yep, brilliant. And like that. Yep. Okay. This is one of those sort of processes which you never get right first time. Somewhere along the line you'll drop a zero or stuff up a number. There's always lots of scribbles, bits crossed out, try it again. But you need to have a think about roughly what you expect the answer to be. And then when your answer comes out, you can say, is that reasonable? So I'm expecting the answer here in the x direction to be just a little bit less than 125, because the triangle should weight it back. So close to, but not quite 125. And I'm expecting the middle, what do we got? We've got 800, the whole thing's 925 deep. And it looks to me like this thing's probably a bit fatter than that thing. So I'd expect it to be a little bit more than halfway down. So maybe, I don't know, 480, 500, somewhere in that ballpark, roughly. Just very, very roughly. Okay, so what do we got? So the x bar is the sum of the AX is divided by the sum of the A. So that's 2598450 divided by the total area, which someone's worked out for me, and it is 122.5. That sounds pretty good. That's close to, but not quite 125. So I'm buying that. Sounds reasonable. And the Y bar is the sum of the YAs over the sum of the A's. $474.1. Was my guess, somewhere around about 480 or something I said, didn't I, roughly? So looks good. Those two numbers both seem reasonable. I'm happy to take those and go, looks good. No guarantee that we didn't stuff up in here and that shouldn't have been an 8 or something. It would have made a minor difference. But in general, it looks good. We haven't suddenly multiplied something by 10 or left a 0 off the end of some number. That would change it quite dramatically. So it looks reasonable. Okay. So exactly the same process as the previous job, except you've got to be able to work out the areas of circles, semicircles and triangles, and you need to know that for a triangle, the centroid is a third of the way along the sides, and for a semicircle, you need to have access to this formula, which should be given in an exam, but if it's an assignment, you need to be able to find it and work it out yourself now that I've given it to you once. Okay.